Welcome to 24 Hours of PaaS Cross-Platform SQL Server Management. We're excited you can join us today to Marko's Hotti session, Modernizing Mission Critical Application with SQL Server 2017 on Windows, Linux, and Docker containers. This 24 Hours of PaaS event consists of 24 consecutive live webinars delivered by expert speakers from PaaS community. This session will be recorded and posted online after the event, so you will receive an email letting you know that recording is available. My name is Cesar Oviedo. I am a Data Platform MVP and will be your moderator. I have a few introductory slides before we can start with Marko. Okay, next. If you require some technical assistance, please type your questions into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you can ask some questions throughout this presentation. Feel free to enter your questions at any time, and once we get to the QA portion of the session, I will read your questions aloud to the speaker. You are able to zoom in on the presentation content by using the zoom button located in the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is really important for us. Please take a moment to complete it. This will pop up after the webinar ends. Next. I'd like to take a moment to thank our presenting sponsors, Quest, Idera, SentryOne, and Microsoft. Microsoft empowers users with new insight throughout familiar tools with while balancing the need for IT and manage user-grade content. Deliver access to all the data types across structured and unstructured sources. I'd like to thank our supporting sponsor, Redgate. The staging of 24 hours of PaaS will not be possible without their generous support, and they are the reason this event is available for free of charge. If you like to learn more about our sponsors and you sign in for information and how they can help you, please visit a sponsor page on the 24-hour web page. Finally, PaaS Summit is the PaaS community flagship event and is happening this November from 6 to 9 in Seattle, Washington. PaaS Summit is the largest conference for technical professionals who leverage in Microsoft Data Platform. Immerse yourself in deep dive technical sessions, learn more of the best practices, and discover new tips and tricks. For more information, register at visit paassummit.com. And now let's go next with Marko Hotti. Marko Hotti is a technical product manager for SQL Server at Microsoft. So Marko, please share a little more about you. We can just start with that presentation.
Okay, thank you, Cesar, and good evening, everyone. It's 10 p.m. here in Seattle. I'm broadcasting from home. So I'm Senior Technical Product Manager for Microsoft SQL Server here in Microsoft Corporation. I started off my DBA career as an Oracle DBA in the 90s, and I was actually employed by Oracle back in Finland for many years, and then joined Microsoft year 2005 and relocated to US and now work in the corporation since 2015. And that's about me. Let's go to my presentation, which is about modernizing mission-critical applications with SQL Server 2017 on Windows, Linux, and Docker containers. We had a very interesting discussion before this session with Cesar about mission-critical, and this could be even business critical because the scope of this topic is not really just to talk about high availability and disaster recovery, which is kind of the traditional thinking for people when they hear the word mission critical. I think most of the solutions today that customers are building and what they need to run their businesses are actually business critical or mission critical, whether that be, let's say, business intelligence solutions, big data with advanced analytics or whatnot. And so so this is really kind of the framework where I'm putting my story. Now, everything starts with this slide, which is about powering your entire data estate with SQL Server 2017. So what we mean with a data estate, we mean that first of all, you have all kinds of data sources. You have OLTP type of applications. You have mobile applications. You have your ERP applications, line of business applications. You have all kinds of data, whether it's traditional relational data, whether it's graph data, social media data, IoT data, and media data. All this data is very critical for the business today, and there is an ever-growing amount of data today that customers want to embrace in order to be able to do digital transformation for their businesses and in order to be able to run their business smoothly and in a smarter, more intelligent way. So when we talk about data management specifically, so data estate entails operational data where SQL Server is doing really well. We are the leader in Magic Quadrant of Gartner, leading in TPC-E benchmarks and so on. Operational data is typically the transactional data that you want to run, and I'm going to talk a little bit more about that. Data warehousing is obviously a very traditional way of storing his historical transactions and understanding how your business have been involved. SQL Server has doing really great in terms of TPC-H benchmarks. And big data today is also very important. Big data is something that is typically semi-structured or non-structured data that just comes in from different sources. It could be sensor data, log data, and so on. And this is also very important data for many businesses, because if you unlock the big data using technologies like machine learning, you will be able to unlock lots of insights from this data. And if you can correlate that data with, let's say, your ERP data or CRM data, so then you will be able to make better decisions. Data integration is obviously very important. SQL Server has SQL Server integration services, which is a great tool for extract, transform, and load, connecting to different data sources. You can use a polybase feature in SQL Server to connect to big data sources and so on. And obviously, one of the reasons why many customers love SQL Server is the business intelligence. We have analysis services, OLAP cubes. We have the tabular mode, which is the in-memory mode for analytics. And we also have advanced analytics capabilities, which is something new that we introduced in SQL Server 2016 as R services. And now in SQL Server 2017, we actually support both R and Python in machine learning services. Security is a very important topic. As you all know, probably know, SQL Server, all the versions of SQL Server, including Express Edition, which is the free edition of SQL Server, Standard Edition, and Enterprise Edition have the same security features. So if you are building a new solution, you can start with the Express Edition and have the security built in. You can leverage dynamic data masking, row-level security, auditing, and all these great features from the very start, and then deploy your environment later onto Standard or Enterprise Edition. Security is also very important, thinking about the new GDPR regulations that take effect in May in European Union. GDPR stands for General Data Protection Regulation, and it's kind of a framework where which defines how sensitive data like customer data should be stored and maintained. Today, SQL Server is not only about on-prem solutions. You can run SQL Server also in the cloud. in Azure VMs, or you can also use the PaaS services. We have introduced managed services, managed instances for SQL database in Azure, which has almost exactly the same compatibility in terms of the database engine features, and it's still in public preview, but it's going to GA later this year. And it's not only about the choice between on-prem or cloud. We also have support now for Linux operating systems, which is very important for Microsoft, because we saw that many customers would love to move to SQL Server, but they don't necessarily like Windows Server. And so we wanted to make sure that all the greatness that we have in SQL Server is also available for customers who prefer Linux operating systems such as SUSE or Red Hat Enterprise Linux. And Docker, which is a very important technology for container technology for DevOps, is a very popular technology for developers who want to rapidly deploy their application and database in the same kind of environment, and then move the environment from development to testing and then to production. So containers are something that I'm going to talk a little bit more in my other session, which starts 2 hours from now. Obviously, there is no lock-in in terms of what sort of application frameworks you want to use. You can use .NET development languages like C#, C++, and so on. But today we see lots of open source applications out there. We support all kinds of open source development languages like PHP, Ruby, and Node.js. We have connectors for all these application frameworks, so that even open source developers can now start building applications and leverage SQL Server in their solutions. And Java is obviously one of the supported application development languages. Okay, so I have a few slides about the new features of SQL Server, and I already mentioned a few. Linux and Docker support is probably the biggest thing, really. It was actually a very big news 2 years ago when Microsoft announced in New York, that's in one of our events, that we are going to bring SQL Server on other platforms as well. And so today we support Red Hat Enterprise Linux, Ubuntu, and SUSE. And we also support Docker containers, which is a very nice way of having lots of SQL Server instances containerized. Containers are kind of operating system level virtualization type of solution. So instead of virtualizing the hardware using hypervisors like Hyper-V, we are only virtualizing the operating system, host operating system libraries that are needed to run the application. And so the footprint of a container is much smaller than that of running SQL Server in full operating system, where there are lots of other resources as well. And so that's something that is very interesting and also very new to the traditional SQL Server audience. We also introduced a series of new family of features. We call them adaptive query processing. So it entails a few things like faster queries just by upgrading. Essentially, this is kind of the net benefit that you get by upgrading, let's say, from SQL Server 2016 to SQL Server 2017, because now the query optimizer is smarter in terms of detecting all kinds of different anomalies in the query execution plans. It will be able to analyze interleaved execution, batch mode memory CRAN. It enables batch mode memory CRAN feedback, and also it enables batch mode adaptive joins. And these features are enabled by default in SQL Server, so that your applications runs faster. I'm going to talk a little bit more about adaptive query processing later. Another very interesting feature that we introduced in SQL Server 2016 is automatic tuning, which is essentially a technology that allows you to identify and optionally fix query execution plans based on different kind of scenarios where we see that the query plan is having a regression. So some execution plan that used to work very well is not giving the same performance anymore because of, let's say, application changes or the data changes and so on. In Azure SQL Database, we have additionally, we have a feature called automatic index management. I'm not going to talk about this because the session is about SQL Server bugs, but it's good to know that if you are running Azure SQL Database, so we have lots of added intelligence there to enable index management and to fix performance issues. We have tools in Azure Portal where you can find recommendations on how to improve the performance of your database, for instance, by adding new indexes and so on. And so this is a very interesting scenario for customers who are using past solutions. Graph is something that we introduced in SQL Server 2017, and it is essentially a technology that allows you to store many relationships in a smarter way than using the traditional relational schema, where you have tables linked to each other using primary foreign key constraints. Essentially, Graph allows you to model very complex networks. Imagine, for instance, a social media application where you have people, you have likes, you have different kind of pages, people share common interests and so on. And you want to understand how these different relationships work together. So Graph databases typically solve that problem very easily by using nodes and edges. I'm going to show us a short demo about how that looks like later on. We also enhanced performance of natively compiled T-SQL modules. We have now support for OpenJSON, for JSON and JSON. Cross-apply operations and computed columns. We added some new string functions like trim, concat, WS, translate, and string AGG aggregate with support for within group order by. And bulk import now supports CSV format files and Azure Blob storage as file source. So lots of investments over there as well. Native scoring with T-SQL Predict is something that is related to advanced analytics. So if you have a trained model, let's say you are using R for doing predictions or of your data based on the transaction. So what you can do is you can store the trained model in a binary format in a table and then reference that using the predict function, and that allows you to do native scoring based on the data that you have just inserted in the table. So this is something that actually works on Linux platform as well, even though the all-up kind of machine learning services is not supported on Linux platform just yet. One of the improvements in SQL Server 2017 is a resumable online index rebuild. Imagine a scenario where you have like very large data warehouse where you are maintaining very large indexes and you want to reorganize them, rebuild the indexes. Sometimes they are very resource intensive operations, and sometimes you have a situation where you want to free that resource to something that is business critical. So you can pause the index rebuild operation and then resume later on once this more important task has been completed. And if you are familiar with always on availability groups, so we now support clusterless configurations. So there is no need to use Windows Server clustering or pacemaker clustering if you want to use availability groups and the readable secondaries for read scale using the round robin technology that we have in availability groups. So read scale is obviously in this clusterless configuration just for scaling out reads. If you want to do failovers, so you have to do them manually because there is no clustering software. But it also gives you more flexibility in terms of how you want to deploy availability groups, even between two operating systems, Windows Server and let's say Red Hat Enterprise Linux. In integration services, we added new features, essentially integration services scale-out configuration, which allows you to have a you can have worker nodes that are actually doing the hard work, and then you have a control node which is managing the process, and this single master will be the one that controls how these workers execute the data flows. Integration services is something that also works on Linux platform today. So you can deploy SSIS packages on Linux computers and run and schedule the packages. We wanted to bring SSIS on Linux mainly because SQL Server on Linux has all the data warehousing and database engine capabilities. Essentially, many customers are, for instance, migrating Oracle data warehouses onto SQL Server 2017 running on Linux. And so it makes sense to also have the ETL processes running on Linux platform. We do currently have some limitations that are very well documented in the documentation, but it's there so that you can try it. And then some connectivity improvements, connect to OData feeds, Microsoft Dynamics AX Online and Microsoft Dynamics CRM Online. Connectivity is very important, and we keep adding these new connectors to SSIS as we move forward. Analysis services has lots of new features. It has object level security for tabular models, some get data enhancements, support for new data sources, a better end user experience for tabular models. And we actually enhanced the racked hierarchy support by hide members property, so that when you have racked hierarchies in your dimension, so you can hide the blank members from that. It's something that customers were looking for. So when you are running a report using tabular mode as a data source, so we are hiding those leaves that don't have data. Reporting services now has commenting, and it's available for reports. You can also add with the comments, you can add perspective to your reports, and you can collaborate with others. We increased the support for DAX. So for instance, Report Builder and SQL Server data tools, you can create native DAX queries against supported tabular data models by tracking and dropping the desired fields in the query designers. So lots of improvements in that sense. And one big change is that SQL Server reporting services is no longer distributed through the SQL Server setup. So if you have tried installing SQL Server 2017 on Windows platform, you have probably noticed that it's a separate download link. So you will go to our download page and download the Power BI report server. And the reason why we are doing this is that the Power BI service in the cloud is evolving very rapidly, and we also wanted to have parity between the cloud service and what SQL Server Power BI report server can offer in the on-prem world, if you will. And then machine learning services has a lot of new features. The big thing is that we now also support Python. So you can do your data science using both of the lingua francas that are currently widely used in machine learning services. We have RevoScale Pi runtime, which is equivalent to the RevoScale R. Essentially, what it means that when you run Python scripts and Python-based models, machine learning models on SQL Server 2017, so we can fully parallelize the algorithms and leverage all the cores available on that operating system. So that's when you are doing predictions or churn analysis or let's say fraud detection or whatever you want to do with machine learning. So you would be having a very good scale there. And we actually also support GPUs, so graphical processing units. So if you have NVIDIA graphic adapter, on your desktop and you're running SQL Server locally on a desktop, so we can leverage the added performance of the GPU processors. And one very important thing also, which is something that I'm actually going to demo, is Microsoft ML, which is pre-trained models for doing different things like sentiment analysis. So let's talk about modernizing and why SQL Server is being so widely used in these new modern scenarios. So first of all, one of the kind of the modern scenario for business critical applications is really the HTAP, which is a abbreviation from hybrid transactional analytical processing. So if you remember, in SQL Server 2014, we introduced in-memory tables. And if you have memory optimized in-memory tables where you do leverage the in-memory for super fast transactions, what you can do is you can add a clustered column store index on top of that in-memory table and run queries, let's say ad hoc queries against the in-memory table without affecting the performance of the transactional performance of your application. So what this gives you is real-time insights into your operational systems. You have some mission critical, business critical, let's say, web store application or order entry application, and you want to see the status and where we are. So it allows you to give this information. We also have the improvements that I also already mentioned, adaptive query processing and automatic plan correction. And so let's talk a little bit about clustered column store index first. I'm going to show you a short demo. This is really quick, where I'm going to just show you the performance of clustered column store. When I did this similar presentation a few weeks back in a local user group, so it was a surprise that so many people didn't really know about clustered column store. So what I have here is I have a table called Fact Reseller Sales XL, which is using page compression, and it's a relatively large data warehouse table which doesn't have any additional indexes, and I'm running a relatively typical data warehouse query against this table. I drop the clean buffers, use the drop clean buffers dbcc command to clear the buffer cache so that I don't have any page data on the memory. And I'm going to run this query. And this query is now using the disk-based table. We are using page compression mainly to save some disk page. And this query took 30 minutes to return 42 rows. So let's run the same query against same data, but now at this example, the fact reseller sales XL table actually has a clustered column store index. So it's actually the storage mode for this data, and so what we are doing is we are compressing all the columns in 1 million row segments on the disk, and we are running the query where we are only picking those segments, column segments from the disk that are relevant for the aggregation. So I'm going to do dbc drop clean buffers again and run the same query against clustered column store. And as you can see, the query performance was less than 1 second and gave the super fast result. Now the HTAP essentially gives you the same performance as well. Okay, let's move on. I already talked about adaptive query processing a little bit. So essentially, one of the scenarios is, for instance, a scenario where you have, let's say, wrong or stale statistics about the cardinality of a column that you're touching in your query. So what will happen typically if we have a memory spill is that SQL Server for that query operation reserves too little amount of memory to process the query, and since there's too little memory, so there will be spillover to disk, essentially temp DB. And now SQL Server is able to detect this kind of this type of memory spillovers to temp DB and grant more memory for the subsequent similar query, so that next time you run the same query, it actually SQL Server reserves more memory, or the required amount of memory for that given query, and then you wouldn't be doing temp DB writes, which are typically very slow and slow down the query. So this is essentially one of the improvements in the query engine that are automatically enabled when you update to SQL Server 2017. And so if you have had any experience about memory spillovers, so you would see lots of query performance improvements in your existing environment with the same data. The automatic tuning is very interesting because in SQL Server 2016 we introduced technology called Query Store, which hopefully many people know and use. Query Store stores telemetry data about the compile time and execution time statistics about how the query performance or how the execution plans are working, and there is a nice graphical user interface in SQL Server Management Studio where you can see the different execution plans for the query, and if you see that you have an execution plan that works better, so you can force that execution plan, and so subsequently when we have the same query against the database, SQL Server will use that force query. Now, sometimes there might be, however, regressions. These are typically due to new data loads. You have some new data and your statistics are not up to date. There might be some application changes as well. And this will cause a regression that will slow down the query. And so if you enable automatic tuning, automatic plan correction in SQL Server, so what we can do is we can detect these regressions and automatically fix these problems. I'm going to show you a demo about how automatic tuning works, and for that I'm using SQL Operations Studio. I believe the next presentation after mine is actually about the cross-platform tool called SQL Operations Studio. So this works both on Windows, Macintosh, and Linux operating system. A very lightweight tool for managing SQL Server and other databases. So what I have here is I have a database called Wild World Importers. It's running on my SQL Server instance on Red Hat. And what I'm going to do is I'm going to start this script first. I'm going to collect performance data from sysdmOS performance counters, so from this view. And I'm interested in counter name called batch requests per second. So this one will give us how many batch requests we are doing. The higher value, the better. That means that SQL Server is able to get more data from disk. So it's using optimal pathways to fetch the data. And I'm going to query that counter infinitely and store this data to a temporary table called TBL perf count. So I'm going to run this query in the backend to collect the performance data. Now I have a store procedure which runs a report. So for clarity, I haven't really, I'm not showing the report here, but I want to run a report and get a baseline about how well my environment is performing. So in this script, I'm now querying the temporary table where I have the performance count, and I'm going to run this so that we see what the performance of my query is currently. And what I'm going to do is I'm going to look this as a time series. So you see now that initially there were no batch requests, but it went up. So we have a baseline here. This is the current performance of SQL Server. So let's make a regression for this query. So I have a stored procedure which changes the data a little bit. So I'm going to run this. And let's take a look at the batch requests again. So I'm going to query the performance counters again using this temporary table. And let's see it as a time series. So as you can see now, the performance dropped. So the same report is now running much slower. So there was a regression. In SQL Server, we have a query store view called DMDB tuning recommendations. So let's run this query and see what the recommendation to fix this is. So it says, first of all, it tells me that the average query CPU time changed from 88 milliseconds to 391 milliseconds. That's huge. And there is also kind of a proposed fix. Automatic tuning option not enabled. So I definitely want to do that. I want to fix it. So I want to run alter database automatic tuning force last good execution plan, and I will execute it by running a auto tune stored procedure that I have already created. So now it's run and the automatic tuning feature is on. So let's run the batch request query again to see where we are now. So we see that this was the time when we were, the execution plan was regressed. And this is the point where we fixed this by enabling automatic tuning. And we see that we are back to the baseline where we were initially. So this is kind of a simple demo to demonstrate the benefits of automatic tuning. Definitely something that you want to turn on if you see lots of regressions in your queries, and a great feature for improving the performance of your mission critical or business critical reporting. Okay, let's move on. I have lots of topics because SQL Server is such a huge, great product. So let's move to my next slide. I'm not going to show a high availability demo here. I just want to call out that SQL Server availability groups, which is the always on feature that we added in SQL Server 2012. It keeps improving all the time, and we now support also cross-platform availability groups. This is the configuration where you have, let's say, primary and one secondary running on Windows, and then one of the secondaries running on Linux. And this could be, for instance, a scenario where you want to manually failover from Windows platform to Linux. For instance, if there is like something like operating system related zero-day bugs that needs to be fixed, but you still want to keep your mission critical environment running, so you can move the primary workload from one operating system to another. And one of the scenarios would be, for instance, migrating from Windows platform to Linux. So this is something that customers actually have been doing now with SQL Server 2017. The data warehousing, definitely something that we are the leader in terms of TPCH benchmarks. We actually did a 1 terabyte benchmark a year ago comparing SQL Server 2016 on Windows operating system and SQL Server 2017 CDP 3 or 2, I don't remember anymore, but it was essentially running on Red Hat Enterprise Linux. And you can see that actually SQL Server 2017 performance on Red Hat on a similar hardware was slightly faster. And so so you can, this is kind of a proof point to the fact that SQL Server on Linux operating system works at least as fast as the Windows version of SQL Server. And I want to call out one thing. So we are also working on reference architecture. So if you are familiar with Fast Track, so data warehouse Fast Track is something that we do with hardware vendors like Lenovo, HP, and so on. These are balanced architectures where you have pre-installed disks, a certain amount of memory and cores, CPU cores, that gives you the best performance for fast data warehouse loads and fast queries. So if you are interested in reference architectures, you can find more information from our web pages. Then I want to call out the queries, the graph capabilities. So this is something that is very interesting for application developers who need to model new modern applications with lots of many-to-many relationships. So I'm just briefly going to show you a demo about how graph queries look like. So graph queries, or the graph tables are essentially, there are two types of tables. There are so-called node tables, which are typically entities or nouns. So for instance, we have a customer table here, which is defined as a node. And then we have, let's say, edge nodes, edge tables, which are typically verbs, or they define the relationship between these entities. So for instance, we have a table called bought that we define as an edge, and then we essentially connect the edges using the node. We connect the nodes using the edges. And so in this scenario, for instance, and I'm running out of time, so I'm doing this kind of a shopping basket analysis, and I'm doing recommendations based on who have been buying products and which products have been bought together. So this is kind of a typical scenario. So you can see that this graph query with a match predicate here looks very different from the way you would do it using traditional tables. You would probably need to join lots of different tables together, and the query syntax would be super long. So graph syntax, or the graph extensions in T-SQL, they make things easier. And this is work in progress, so we are adding new capabilities to graph, thinking about the future releases of SQL Server. Okay, I'm going to show a few more slides, and then we have time for questions. So obviously, most of you know the business intelligence capabilities. In SQL Server 2016, we introduced mobile BI, which allows you to define beautiful dashboards that scale to any type of form factor, different types of devices, iPads, iPhones, Android phones, Surface tablets, and so on. And you can also take these mobile reports offline. So if you download the Power BI application from Play Store or App Store, you can then connect the Power BI application to your on-prem SQL Server reporting services URL, authenticate yourself, pick those dashboards and reports that you are interested in, and take the data, take them offline. So you can also do offline browsing of your business reports using this capability. Here is a kind of a example of an architecture where we are using analysis services. So analysis services now has lots of different connectors in SQL Server 2017, which allows you to connect to additional databases, Azure stores, and a diverse set of modern data sources. And you can then transform all the data coming from all these data sources into in-memory tables in the tabular model, and then do visualization using your favorites tool like SSRS or Power BI. And tabular mode is definitely something that most of the new customers are implementing, because they give the in-memory performance that traditional OLAP cubes don't have. So they are much faster. And then the real-time intelligence with machine learning. So here is an example of how to leverage in database in-memory OLTP and in-memory clustered column store together with machine learning services. So what you can do is you can ingest lots of data in new data in your operational database. You can optimize the queries for analytics using clustered column store. As you remember, adding clustered column store on top of in-memory tables doesn't affect the transactional performance, but we need to move the analytical data to machine learning services fast. So this is kind of the idea. We want to kind of optimize the pathway of this advanced analytics using all the in-memory capabilities. And so once we do the predictions using either R or Python, so we can store the predictions in an in-memory table, super fast inserts, and then visualize them in Power BI dashboard. This is kind of one example of how to do real-time intelligence using machine learning services in SQL Server. And I'm just briefly going to show you a cool demo about sentiment analysis in SQL Server machine learning services. So what I have here is I have a database instance called ML demo, and I have a database called TPCXBB 1 gigabyte. So this database has a table called product reviews. So I'm going to show you just briefly what that has. So there is a PR review content. We have like customer reviews for products. So this could be something that comes from, let's say, Twitter APIs or other social media sources. We store it either in SQL Server, or we could even use Polybase, which is the big data integration in SQL Server, so that we actually store the sentiment data in a Hadoop cluster, and then use Polybase to connect to the Hadoop cluster using external tables, and then we just query the external tables using SQL Server. Now, in this example, I'm leveraging Microsoft ML packages and a pre-trained model called getSentiment. This one is trained to understand English text, and it essentially will automatically give you the sentiment of your review. So this is kind of the scenario. Everything in this script in red is actually Python code. And this is where we call we'll query the PR review content database, and then we create a stored procedure that uses the script that we have here. So sentiment scores, RX futurize, and so on. So the getSentiment function will be used in this stored procedure. And when I run this query just quickly, well, it will take some time to run. So we will see a nice query result where we have automatically analyzed whether the customer product review text is giving a positive sentiment or neutral or negative sentiment. Very common scenario what many enterprise customers are trying to do, and we kind of wanted to make this very easy for customers to implement. All these demos that I show, by the way, so they are available on GitHub. So if you go to github.com and then look for SQL Server samples, so you will find lots of different scripts, and even this one is available over there with the instructions on how to do this demo. So as you can see, we have the review text here, we have a score, and then we have a very simple evaluation of the sentiment, whether it's negative or positive. Okay, just a couple of slides, and then it's time for questions. So Security is something which is very important. Always Encrypted is something that is very unique to Microsoft and SQL Server, which allows you to protect both data at rest and when it's moving from the disk to server memory and when it's moving over the network to the client side. The cool thing about Always Encrypted is that it allows you to query encrypted data without unencrypting it first. And so this is something that you probably want to implement. It doesn't affect your application, so it's relatively easy to implement on the database side. What you need to do is you need to provision the column master key, which protects the column encryption key that is being used to encrypt the sensitive data in the database. And with these two keys, you can then make sure that your data, sensitive data, is encrypted all the way from the disk to the client side. And we also already talked about the platform of your choice, so I'm not going to spend time in this one. Important thing is to understand that SQL Server engine is pretty much the same that we have in Azure SQL Database and managed instances, and also in Azure SQL Data Warehouse. And so if you are looking for a PaaS solution, so these are the guys that you want to look at, and specifically managed instances, which is not specifically called out in this slide, is something that is very cool because it has the full T-SQL surface area capabilities like CLR functions and agent jobs and so on that SQL Server Box has as well. And so managed instances is definitely something that you want to do when you want to do this kind of migration to the cloud with lift and shift type of scenario. And about Azure migration, just to notify you, so Rohan Kumar, who is the corporate vice president for SQL Server, on our engineering team, and Corey Sanders, who is corporate vice president for Azure Compute. So they will be having a Azure migration webcast in Thursday, May the 17th, 10 a.m. Pacific time. So if you want to learn more about how to migrate to Azure and let's say managed instances or other PaaS services that we have in the cloud, so please join the webcast. Here's the link. And then I have some resources here as well. What's new in SQL Server 2017 and SQL Server release notes, which are essentially pointing to our online documentation. Okay, now time for questions, if any. Cesar, have you any questions that people have been asking?
Yeah, we have some. Just to let you know that we have maybe 5 minutes for answers.
Yep, that's fine.
So,
and we can take,
Okay. Does column store index work for log data?
Clustered column store index works for log data now in SQL Server 2017, yes.
Yeah. If the query is not writing in a separate way, say functions, expressions in predicate, where adaptive queries improve performance?
Sorry, can you repeat the question?
If the query is not writing in separate way, say functions and expressions in the predicate, is going to the adaptive query improve the performance? I guess it's a little some.
Yeah, so this depends on the execution plan and the kind of the scenario. It's kind of a wide topic. Maybe the person who had this question, maybe he can send the question to me with email. So okay. First name dot last name Marko.Hotti Microsoft.com, so I can take it offline.
Okay, next question. Can I have AG, probably availability groups, without a domain?
Yeah, so this is actually something that we introduced with Windows Server 2016 and SQL Server 2016. So you can also have domainless clusters with Windows Server 2016, and we also support multiple domains. So part of your cluster running on Windows Server can be joined to a different domain than the rest of the nodes.
Okay. Automatic index support, both row-based and column store index.
Yeah, so this is Azure SQL database feature, and we are working on adding new intelligence in the past services all the time. So I believe clustered column store indexes recommendations should be already there, but I'm not quite sure. So need to take a look at the documentation.
Okay, we have some time for some more questions. In-memory support cross-database queries.
So in-memory support cross-database queries. Cross-database queries. So essentially, the in-memory technology that we have in SQL, we have in-memory native in-memory tables or memory optimized tables, and you can definitely do cross database queries where the data tables queried are in memory mode, but we don't do any additional in-memory optimization other than we just query the tables in different databases super fast, and the same with clustered column store, in-memory clustered column store.
Okay, one more. Which is better for performance, Python, R, with SQL Server, or the standalone?
So that's a good question. So with standalone, I believe the person means SQL Server machine learning services standalone installation, which doesn't include SQL database engine installation at all. So essentially, there shouldn't be any performance differences. Because the runtime, how we execute both R and Python models, the execution engine is exactly the same, and we do a similar type of optimization in terms of parallelism and how we leverage the memory. But they are kind of two different scenarios, obviously. With in-database machine learning services, you are actually very tightly operationalizing machine learning services with your operational database or your operational data warehouse. So in that sense, that is more performant because you can just query the data and process the data through machine learning services as close to the data source as you can. And with a standalone, there is a little bit more data movement involved, which affects the performance.
Okay, I guess that is all what we have. So
okay, thank you very much for your questions, and I think you want to talk about these slides.
Yeah, there is an additional slide. Yes, just 1 second. Oops, what is that? Okay, make sure to stay tuned for the next session, SQL Operation Studio, a new multi-platform tool for SQL Server database development, administration, and monitoring. Okay, so basically, thank you everyone for joining us today. Thank you, Marko.
Thank you, everyone, and hopefully you start installing SQL Server and get excited about it. We are very excited about it. Okay, have a good night, everyone.
Thank you, bye.